Hi guys. Today we're going to be looking at some more analysis skills so that whenever we do get back to school, you'll be able to do lots and lots of practical work and be rather adept at writing up this stuff. There are two different things that we're going to look at today. Both of these should be in your email inbox. The first one that we're going to have a look at is this sample data set called one mass time. And there are a couple of things straight away that you'll maybe notice that I don't particularly like about this straight away. If you remember back to last lesson, significant figures were a rather important thing to tell us about the precision of any sort of a measurement. And here we've got the measurement precision in the time. So this is like the best possible precision that we can have. Okay, we know that we're not going to be perfectly correct, but we think that the absolute best is going to be within this. So every single one of these other numbers should be to one decimal place. You can see that we've got two decimal places in a lot of these. So if I hold on, shift, select those, go to home. I always get it wrong the first time. I don't know if anyway, click that a few times until you get everything to one decimal place. You will notice over here in our mass, we have an uncertainty of plus or minus 0.1 grams. That seems very, very small. I can't remember where this data set came from. It doesn't really matter. But if we've said that this is to one decimal place, well then all of these also need to be to one decimal place. Okay, it's important that your measurement precision matches the precision of all of the things in your column, and each of your columns should have a consistent measurement precision as you move down through the column. So that all looks pretty good so far. Now here, to find an average, you could, if you wanted to, click in your cell and type equals that one plus that one plus that one plus that one plus that one divided by 1 through 5. Wait, I need another bracket. Always a good idea to put equals and then a bracket. It looks a little bit like a sad face, but it saves you some time later. So that'll work. But then if we delete that, this is no longer an average because this is divided by 5 and we only have 4 values here. So if instead we use the average command, which is much, much, much quicker, and open your bracket, click and drag. You can type it in if you put in the first cell and the last cell separate by a colon, press enter. And now if we do delete one of those, we still get an average value of what was left over. So that is absolutely the way that you want to do those. But we need to have a little look at uncertainties and error bars and lines of best fit and other such fun things. Mr. Crochet, tomorrow we'll talk about how we can combine errors, and I'll maybe take you a couple of steps into that towards the end of this. So if we want to find our uncertainty in the actual measured values of time that we've got here, we want to find the biggest value and the smallest value and see what that range is. If we've got a really, really small range, well then we're going to have quite a small uncertainty. If we've got a really large range, well then we've got quite a big uncertainty. So the range, or half the range, is a really good indicator, and that's what we're going to use. So if we start off and equals, let's put in our bracket, and we want to find the maximum values. We just type max, open up another bracket, click and drag it across, and we've got our first cell, last cell, and our colon in the middle. Close our bracket, take away, I don't need that, min, which we'll find is the minimum value in the range that we've selected. Close our bracket, another bracket, divided by 2, and this will give us what is known as our absolute. Our absolute uncertainty in time. Now, this is an actual value that is a time. So our absolute uncertainty should have units. Now, we'll talk a little bit about relative or percentage uncertainties in a future lesson. Those won't have units because they're like fractional and you're dividing things. A little bit like efficiencies when you do those. But this is an actual time, a time subtracting a time, so it will be a value in seconds. Now we don't need to do that for all of these. If we've done that, we put it in here. This tiny little green box at the corner, you can maybe just see when you move your cursor over it, it changes from a white cross to a black cross. Get the black cross, click and drag, and that will automatically do all of those for you. Now there is something important for us to check at this stage. We said this measurement uncertainty up in the top, that this was the smallest possible uncertainty that you could have. Okay, now you'll notice this is 0.13, it's fine, but here we've got two values where we've managed, possibly by luck, maybe this value is a slight exaggeration, or maybe we're lucky, we don't know, but we've stated that this is our absolute smallest uncertainty. So for each of these, I'm going to change it to 0.1. Okay, with these, again, we want to have a consistent number of significant figures, and same with our means. So let's bring this all down to the same. There we go. So now we have our average values or mean values. We have our absolute uncertainties in those means. We've got a measurement uncertainty in the mass. So I think we're ready to start plotting some graphs. So here, our mass in this experiment was our independent variable. And it is customary. It doesn't always have to happen. And we'll look at that again in the next example. But your independent variable, or the variable that you've changed, will normally go onto the x-axis. If we double click up here, we can say this is mass, call it M for short. It was in grams. We'll be coming back to look at these options in a moment, but let's just finish up with that. Go back to Excel, we want our average time. Paste those in there. Double click up here, we have time. We call T for short, and units in seconds. Okay, and that doesn't look too bad. We still get all of the sort of data points that are squished up into the top. So if we come and click on our auto scale button, that sort of suits it a little bit nicer. And then up here we've got linear fit, where you could go analyze linear fit, exactly the same function. It doesn't matter which one you pick on. And oh no, I don't have a line. How terrible. You'll notice here that I've got this little sort of strange black eye shape. It's not actually an eye shape, it's two brackets. Oops, got the wrong one. Doesn't really matter which one you get. But these brackets will denote the points that you're actually looking for with your line. So you'll notice if I've just got one point between these two brackets, that's not enough information for Loggerpro to be able to draw a line. If I've got two, it's straight through those. So as I drag these out, it starts to include more and more of the data points. This is a little bit stuck off the edge, so I'm going to click down here and drag that back a little bit so that I can see that point. Is there one down here as well? No, there's sometimes there's one at the bottom as well that's just off the edge, but no, that's fine. Okay, so next thing we want to do, we want to be able to start to add some uncertainties. So for the mass, pretty straightforward. Because the mass, if you remember, we just set our measurement certainty of 0.1, and that's going to be the same for all of these. So go to options, error bar calculations. This time it is a fixed value. It is a error constant fixed value plus or minus 0.1 and done. And you'll notice that we have minuscule error bars, but they have been added there. Okay. Now for the time, we have a slightly different way to do it. If you click on here, sort of drag this out a little bit, go to data, new data set, and you'll notice that we've got data set 2 that has appeared here inside the same thing. Go back to Excel and find our absolute uncertainties column. Copy that back to Loggerpro. Because it's for time, I will put it into the time column. And then back over here and double click on the actual time values. Still in options, error bar calculations. Still a fixed value. We haven't done anything with percentage errors. It's not an error constant this time. This time we're going to use column. This has then become ungrayed out, and we can click on this and select whichever one. It gives us dataset, mass, time, dataset 2, mass and time, dataset 2 with mass and time that we wanted. So we click on that one, and we're done. So those error bars are a little bit bigger than the ones that we had before. And we can see from our data that we'll see a couple of things. We can see that our seem to have a linear fit, which is good. We've got 1, 2, 3, 6 data points, and they're all, with the exception of this one, which is still very, very close. That line either goes through or it touches all of those error bars, which is pretty good. Now we want to be able to come up with not just our best possible relationship between these. And I can't remember what the, actually, sorry. Yeah, no, I can't remember what this experiment was. It's maybe like sort of changing the mass of sand in a beaker and the amount of time that it took to leave or something. I can't exactly remember. But this was suggesting that we're getting a flow rate, or it's taking about sort of 0.009 seconds for each gram. But we could find the sort of worst possible correct solutions that are still reasonable, but at the extremes of what we think they could be. Now, these are quite nice data points because our error bars are quite small, and maybe you've got something that's quite a bit bigger. And for the sake of showing you this, I'm going to exaggerate it a little bit. So I'm going to change these all to, double them all, say 2, 2, 2, 4. You shouldn't do this. I'm doing this just purely so that we've exaggerated it and you can see what it is that I'm doing. So just by changing those, these have all automatically gotten a little bit bigger. And you can see that we've managed to then get this one that's just crossing through. So to put in some extreme fit lines or extreme lines of best fit, we want to go to analyze, curve fit this time. If you go to linear fit, we'll just get another one of these, which is fine. Click on it and delete. So analyze, curve fit, and you can still put on our straight line relation. Click try fit, and we'll get something in there and press OK. So we can click in this box and we can move it around. If we right click on it and linear fit options, no, hang on. Sorry, my bad. Let me go back a step. Curve fit. Make sure we've got our linear, try fit, and then just over here, do something just to sort of, just to sort of knock it off where it was a little bit, and okay, just to get something that's slightly off. So here you'll see we've got manual fit instead of linear fit. Okay, so we'll bring this over. If we right click in here, linear fit options, and we've got enable line drag at the bottom. Click on that. We've got these three little markers. And what I want is, well, sorry, let me put on my other one as well. Analyze curve fit. That one. Try fit. Okay. This is definitely not what I want. I don't want three parallel lines because what we're interested in are the three different gradients, like our best fit gradient and then our two extreme fits. So these two extreme fit lines, they really should be crossing over each other. I'm not going to turn on the line drag for this one just yet because it gets a bit messy. But if I click on this one and drag it up so that it just brushes the very top of that error bar here, and then over here, do the same. Oh, it's pesky. It's annoying. Do the same thing so that it just brushes the bottom. Okay. Linear fit options. Turn off line drag for that one. Go over to this one. Linear fit options. Enable line drag, and then we've got our little markers on the other one. So with this one, we got the steepest possible one that would fit. With this one, looking for the least steep one possible. So that's not good because I've just gone a little bit too far. So I'll take it back up a little bit. There we go, just touching. This one we got to drag back down a little bit so that it's just touching. Maybe move these so that they're a little bit easier to see what's what. And if you really fancy, you can go in and change the colors of your lines and things. But what we've got now is our linear fit, which is like our best fit, or what would be the answer if you were asked to find what is the relationship between time and mass. But we also have two other values that are still sensible, that still match our data patterns, but they're the least sensible ones that we have. So these are our extreme possible values, and we could use these then to be able to give our plus or minus. So we could go 0.01092, take away 0.00825, divide that by 2, and that would be our plus or minus value for the actual relationship between these. You'll notice as well that because I've been careful, I've put the units in, they've given us the correct units here as well, which is really, really useful. So that is how you will set up and put on your extreme lines of best fit for the first set of data.